Okay, so I'll start recording now. So welcome everyone. I'm Alison from the Southern Cross Postgraduate Association. Welcome to the second workshop on series with statistics can be fun with Megan Lee. So just a reminder that the third part of this workshop is next Wednesday, the 19th. And the last week runs, that fourth and final part runs on April the 26th. Just a quick note while we're here, we're running a couple of in vivo workshops with Dr. Robert Lingard for those that are interested in qualitative research, and that's April the 21st and the 28th. So keep an eye out for those if in vivo interests you. And also Megan will be delivering a workshop for us as well on Qualtrics on May the 4th. So, boy, do we have an action-packed schedule of workshops for everyone, which is excellent. So become a member of the Southern Cross Postgraduate Association, subscribe to our YouTube channel, and I can see that people have accessed the recording from Megan's workshop last week, which is excellent. So I will post the recording up this afternoon and email everyone, which I did last week as well. So thank you very much, and I'll hand it over to you, Megan. Thank you.
Thank you, Alison. Hello, everyone. For those of you who were not here last week, my name is Megan Lee. I completed my PhD at Southern Cross and was an active member of the Southern Cross Postgraduate Association myself. Some of my best friends now I met in the Southern Cross Postgraduate Association, will be friends for life. Really held each other's hands throughout our PhDs. Some of my friends are still submitting, some have submitted, so it's just a really great support network. Yeah, some of the best things that happened to me were through the association. And now I want to give back. So this week, we will be looking at intermediate statistics and SPSS. Last week, we looked at more of a beginner's workshop, and we stepped through how to get your data into SPSS, how to clean your data in SPSS, things like that. So that was a real beginner's workshop. We talked about some tips and tricks on using SPSS and how the views work, things like that. Today, we will be stepping into a little bit more of the statistical analysis side. So today we'll be looking at descriptive statistics, and we will be running correlations and t-tests. The data set that we are using is completely live at the moment. It closed last Monday for recruitment. It's actual data that will be published. I've spent all day yesterday writing my intro and my methods, so should be submitted for publication in the next couple of weeks. So that's a bit exciting. Using something, using a live data set that's got its own problems and issues is really important, because those things happen. Statistics is never a smooth sailing sort of thing. There's things that pop up, there's variables that don't work. So it's really important that we are using this kind of live data set and seeing that as they happen. If you want to contact me with any questions that you have, feel free to email me at my Bond University email. You can also go and check out the research that I've done during and after my PhD at my website. Also, all my conference stuff is there, posters that I've submitted, articles in the conversation, and all of the workshops that I do for the SCPA are up there as well, all the links to the YouTube. So you can also follow me on my socials. I put lots of fun food and mood stuff, because that's what my PhD research is in, nutrition and psychology. Let's get going. So today we will be looking at descriptive statistics. Basically, researchers use descriptive statistics to describe their data set. Pretty simple. They are mainly used on the demographic variables to tell us what our sample looks like, or what the population of people that we recruited looks like. So we will be going into the pretty simple statistics to begin with. So we'll be looking at mean, median, mode, and standard deviation, which are the main ones that we usually use. Then we will be moving into our inferential statistics. Now, inferential statistics are basically the statistics that answer your research question. That's how I look at it. Descriptive statistics describe your sample. Inferential statistics tell you about your hypotheses of your research question. So we'll be looking at that, and then we'll be diving into SPSS and doing a live analysis. Cool, we've been through that. So let's talk about measures of central tendency first. So we've got our mode, our median, and our mean. Can anyone tell me, just using the chat box, because I've got that up here, I can see your answers. Can you type into the chat box what the mean is? Good. And the median? Good, Abby, yes. The average, sum of the variable divided by the number in your data set, that's your average. The median is the middle value, yes. So the medians can tell us a lot more about categorical data. I think a really interesting example of this is that the mean income of Australians is something like $150,000 per annum, whereas the median is only 75. Can you tell me why that might be? 150 grand. Soon, Sarah, soon. Yeah, so it skews the distribution, but why? Why is income in Australia, the average income 150 grand, and why is the median 75 or 80 grand? Capitalism. It actually is. High income earners, yes. So we have a lot of people, well, not a lot of people, we have kind of these outliers at the top end who are making millions of dollars a year that are skewing our average. Whereas the median is a little bit more of a realistic number because it's the actual middle value. If you took all the people in Australia and you divided them in half and you found out who the two people in the middle were and you kind of averaged out their two incomes, then that's giving you a little bit more of an idea about what our incomes actually look like. That's why they use medians when expressing house prices for that same reason as well. So median house prices is always reported because there's all the richies or the high income earners who buy these outrageously expensive properties that push the mean up. So it's not, the mean's not very useful when we're talking about income or house prices in Australia. What about the mode? What does the mode represent? The most common number, yeah. And also the mode is useful when using categorical data. Now, I know I asked this last week, but I'm going to ask it again. On a scale of 0, know nothing about statistics, to 10, know everything about statistics, where is everybody sitting this week? Between 0 and 10. 7, good. 0.5, nice. 3, okay. So we've got a fair range of abilities. Today's one, for those who are 7 and 8s, today's one will be a bit more of a refresher. Maybe we'll find some tips and tricks in SPSS that will help you. But going from next week, it'll be a little bit more on your level. But for those who are 0s to 3s, this week will be really super helpful. Great. Okay, measures of dispersion. So when we are looking at our samples, it's not enough to just know what kind of the average or the middle scores are. We need to see how everybody in the sample ranges from that kind of average. And that's what our measures of dispersion are. And this is why you'll always see a standard deviation reported with an average, because it gives you a little bit more information about the average and the data as a whole. So our range is very rarely used, but it's a really easy way of understanding measures of dispersion. So the range is just the very highest score divided by the very lowest score. That's your range. But the standard deviation is a little bit more intuitive. So a standard deviation basically tells us, on average, so there's two averages in this definition. On average, how far everyone in the sample is from the mean, so from the average. That's what a standard deviation is. And it gives us a really good idea of how close or how far away our range is of people. If our standard deviation is small compared in comparison to the mean, so it's always in relation to the mean. If it's small in relation to our mean, that's quite good. That means that there's not a very big range of people. So say we have a data set where the mean age is 40 and the standard deviation is 1. That means that on average, the people in the data set would range between 39 and 41. So as you can see, that's quite a small range. However, if we have a mean of 40 and our standard deviation is 10, then on average, the people in our sample will range between 30 and 50. So you can see how the standard deviation gives us a much better idea of what our sample looks like. Any questions about the range or the standard deviation before we move on? These are very important concepts to understand before we get into our SPSS statistics today. Standard deviation in skewed data. That's interesting. So because the standard deviation is worked out using variances, and I teach my students how to hand calculate standard deviation so they understand why. The standard deviation, because it's a standardized score, kind of eliminates those who are really skewed. But keeping in mind that the average is already kind of skewed because of that. And this is why when we get into our data cleaning, like what we did last week, we make some decisions about those outliers. And we'll look at that with normality today as well. So that's a very, very good point. You wouldn't want to really have a data set where you had 20 people who were between 39 and 41 and then have someone who was like 13. You'd be really considering what you would do with the 13-year-old in your data set and making some key decisions and writing that in your methods about what you did with your outlying data. Standard deviation you can't work out in relation to the median. So there are other ways of working out range for the median, because the median is usually used on categorical data mostly. Okay, the next most important thing after you understand your measures of central tendency and your measures of dispersion is selecting the appropriate statistical test. Now, a lot of people get this around the wrong way. So they will select their test that they want to do because they're comfortable with that analysis, or they've done that analysis before, and then apply it to a research question, when really it should be done the other way around. Now, last week we did PICO. Did we do PICO last week? We would have, yeah. Where you construct your research question. Now, you should always apply a statistical test to the research question, because if you're asking about group differences, then that's a different analysis to something, a question about relationships or predictions. So I would highly recommend anyone who's doing honours or masters by research or a PhD to really think about their research question, tape it to your computer screen, and be thinking about that before you do your analysis. Always write your intro, your methods, and your statistical data analysis strategy before you go and recruit. Always. And if you are using a biostatistician, always go to them in the research design stage, because I've been given heaps and heaps of data that's impossible to analyze after someone's gone out and recruited thousands of people because they just didn't think about their data analysis strategy. So please don't be that person. All right, so today we will be looking at group differences and relationships. When we're looking at group differences, we're looking at comparing the averages between groups. Now, this is usually done when you are looking at either pre-test, post-test scores. So you test, say you test someone's depressive symptoms, then you make them eat a healthy dietary pattern for 12 weeks, and then you test their depressive symptoms again. That's a group difference. So you're testing the group of people before and after they've done the dietary change. Today, we will be looking at group differences between vegans and vegetarians. So there's another different group. The differences between these two groups is that the vegan and vegetarians are completely different. So different participants in both those groups, whereas the pre and post-test participants are the same. So there's different types of analysis to do when your groups have different participants in each group and when your groups have the same person in each group. So that's really important. We'll look at that today. And then relationships and predictions usually are done on continuous data, whereas group differences are done on categorical data. Relationships are on continuous data, usually 2. So we're looking at the relationship between, say, a continuous score on depression and a continuous score on diet quality. So here are all the different types of analyses that you can do. Now, we're first going to look at group differences, so our categorical independent variables. Who remembers what an independent variable measures? Which one is the independent variable? Which one is the independent variable? Pop it in the chat. The one which others are related to, or the constant? More information, maybe? The explaining variable, the variable that you manipulate. Okay, good. So these are really, really important concepts to have nice and firm in your mind before you do your analysis. A good example of this is that during my honours, I actually got my IV and my DV around the wrong way, and I analysed them around the wrong way, which cost me about 3 weeks of time, and then I had to redo them. So the independent variable in a experimental design is the variable that the researcher manipulates. In a survey design, it's more along the lines of the variable that is predicting the change in the outcome, because the researchers are not really manipulating the IV in surveys. So we call the IV the predictor variable, quite often in survey. What about the dependent variable? What is the definition for the dependent variable? What does it do? What's measured? The outcome of interest. Yeah, so the dependent variable is the outcome that we want to see the change in. So we also call the DV the outcome. I most often call it that. So the IV is the predictor variable and the DV is the outcome variable, the one we want to see the change in. The variable which the value depends on the independent variable. Very good. Yes. And you can quite often have more than one IV if you like. So here are our categorical independent variables. So what do we do when we have a categorical dependent variable and a categorical independent variable? Is we use what's called a chi-square. Now, we won't get into that today because that's a little bit more advanced. Maybe in week 4, we will have a quick look at chi-squares and how to interpret them. It's basically just counting frequencies of each category and whether or not there are significant differences between the frequencies of each category. When our dependent variable is continuous and our IV is categorical, we use what's called t-tests or ANOVA. When there are two categories, like today, we will be looking at vegan and vegetarian, that's two categories, we would use a t-test. When there's more than two categories, maybe vegan, vegetarian, flexitarian, we would then use what's called an analysis of variance. We will do ANOVAs next week, but today we will focus on t-tests. Now, remember how I said when the t-test or when the categories have the same participants in each category, like when we test depressive symptoms before and after a dietary change, so the participants are the same before and after, so they're both the same in each group. That's when we used what's called a paired t-test. When we have participants in each group that are different, like the vegans and the vegetarians, we're making sure that none of the vegans are in the vegetarian group, none of the vegetarians are in the vegan group. Everyone's different in both groups. That's an independent t-test. Now, be really careful because t-tests have a lot of different names. Repeated measures, independent groups. So welcome to the world of statistics where there is more than one term for the same thing. These non-parametric tests here, what these mean, so a parametric test is used when all of our assumptions are met, and we'll get into assumptions in a second. We will be looking at assumptions today. Non-parametric tests are used when our assumptions aren't met. So like Albie said, when there's like skewed distributions where lots of people are all up one end, if we've got major outliers that we can't remove, if we lack linearity, so if we look at a scatter plot, and we'll look at that today, and it's all over the place, it's not, you couldn't put the dots into a linear line, then we would use a non-parametric test. These are actually quite common to use, and they remove the, well, they're a little bit more strict when it comes to p-values, etc. What about continuous variables when we are measuring a relationship or a prediction? So when it says here that when we're testing relationships, we always use continuous variables, but that's not always correct, because in logistic regression, our IV can be categorical, split into two. So like depressed and not depressed. You can also split your DV into two with logistic regression. So most of the time, and most of the analyses that you use when you are assessing relationships or predictions, both your DV and your IV will be continuous. So remember, on that scale, going on a continuum between infinity and negative infinity with 0 in the middle. So our parametric testing when we are looking at relationships between two continuous variables is Pearson's R, or Pearson's correlations. If we have our assumptions are not met, then we use what's called Spearman's, or if we have categorical data, we can use Spearman's. So again, there's all these rules that get broken with the continuous variables always having to be continuous. Simple linear regression is when we have one continuous dependent variable and one continuous independent variable. So if we were looking at diet and depression by themselves, then we would use a simple linear regression. But if we're interested in kind of controlling for confounding variables like age, BMI, gender, physical activity, sunlight exposure, then we would be interested in putting more than one variable into the model. So we'd still have one dependent variable, which would be depression, and then we would put diet plus sunlight exposure plus sleep quality plus BMI into as the IVs, and we would do a multiple linear regression. Now we'll look more at those next week, and someone has asked me to run logistic regression, so we'll do that as well. This week, we're just going to be looking at observing relationships between one continuous dependent variable and one continuous independent variable. And I'll show you both Pearson's and Spearman. It's very, very easy. Okay, any questions about that before we move on to assumptions? Here we've got one. Is that the same as non-Gaussian? Non-Gaussian. I don't even think I've heard that before. For non-parametric tests. Do you mean Bayesian? Bayesian statistics? Yeah. So Bayes' theorem is it's becoming very popular in statistics because it doesn't work on the whole dichotomous P 0.05 ridiculousness that we use at the moment. But it's quite complex. Good question. All right. So before we do any form of statistical analysis, and we will run through it today, we do need to make sure that our variables meet certain assumptions. Otherwise, our results will be skewed, incorrect, and absolutely not right, or you shouldn't be analyzing with your assumptions not met. Keeping in mind, if your assumptions are not met, you can do your non-parametric testing or your Bayes testing. So the most important assumptions for what we're looking at today is independence. Now, does anyone want to give me a stab in the dark about what they think independence might be? The assumption of independence. I'm looking at the 7 and 8s here to help out the 0 to 3s. One observation does not impact the other. Thank you, Albie. So independence means in experimental research that none of your participants have influenced each other's answers. In surveys as well. So you shouldn't get a group of students to sit down and do a survey together all in computers in one room, because they could lean over and influence each other's answers. So the assumption of independence should be met in your study design. If you do your research design properly, you recruit correctly, and your data collection is done correctly, no one in your study should influence each other's answers. A really important factor here is that when you do conduct surveys, particularly online, the same person can't do the survey twice, or it impacts the assumption of independence. So always making sure that you build into Qualtrics, and if you come to the Qualtrics workshop, I'll show you how to do this. Build into Qualtrics that once someone has done your survey, they cannot access it again. The next assumption is linearity. Does someone want to make an educated guess about what linearity assumption might be? Functional, yeah. So linearity basically means that the relationship between your dependent variable and the independent variables, depending on how many you have, should be able to, if you draw a scatter plot, which we'll do in a moment, you should be able to draw a straight line through the dots. If they're kind of like in a wave, the dots form a wave or a U or a W, that's not linear, and then you need to use some form of non-parametric testing. We see a really cool U-shaped relationship in meat consumption and depression. I think I told you about this last week, where 150 grams of red meat 3 times a week is the recommendation for health, physical health. But when Felice Jacka studied this on depression, she found this really cool relationship where any higher than the 150 grams 3 times a week, depression went up, and any lower than 150 grams 3 times a week, depression went up. So that recommendation for physical health was the same for mental health. And if you ate more or less than that, then it created this really cool U shape on the scatter plot. So keeping in mind that even if you get something that's like your assumptions aren't met, it doesn't mean that your analysis is wrong. It means that it's showing you something different. So that whole U shape, we didn't throw our hands up in the air and say, oh, we can't do the analysis because our assumptions haven't been met. We're like, what does that mean? That's very cool. So it actually became part of the results and the discussion, this U shape that we saw. Any questions about assumptions testing before we move on? Oh, we didn't do normality. I missed one. The most important one. Do you want to tell me what normality means? What's the definition for normality? Normally distributed. Yeah, so as you can see here on the normality cartoon, there is a bell curve. What this means is if you put everybody who was in your study and stood them up like in a little car park, most of the people would be here. That's your average. And the amount of people would taper as you go up or down away from that average. Now you want your data set to look like this, because if it doesn't, if it's not normally distributed, something's going on. We've got outliers or it's skewed, and we'd have to do non-parametric testing. Now, one really cool thing about normality is there's lots of tests of normality in SPSS. I rarely use them, or I use them as a kind of as a fact check. You can do histograms, which is what this is, to check your bell curve. But if you, at the recruitment stage and data collection, if you recruit enough participants in each category, if you're doing group differences, or overall, if you're looking at relationships, and you have more than 30 participants either in your data set or in each group, normality is usually met through the central limit theorem. So normality, you can check it through your histograms and your Shapiro-Wilks and the little things on SPSS. But if you've got enough people in your set, in your data set, in your sample, normality doesn't matter. It's more important when you don't have enough participants. Okay. So last week we exported data from Qualtrics and Excel into SPSS. This week we will begin the very next steps in analyzing the data and exploring the data. And as I said, this is all live, so this is what I've been doing this week. Last week you would have seen the data set was very messy. We cleaned up some of the variables. Now they're fully cleaned, and I'll give you a look at that. So the live data set is the Vegetarian for Life data set. We started with 609 participants who did the survey. 143 of those were not Vegetarian for Life, so they got kicked out at the first question, which says, have you been a vegetarian for your entire adult life? When they click no, they just got sent to the end of the survey saying, thank you for your time, but you don't qualify. Another 146 did not complete enough data in the data set. And what we decided as a team, and this always needs to be discussed before you analyze your data so that it doesn't impact your decisions once you see the data, you have to make a decision about how much or what percentage of your survey you accept as completed. So we popped all of the questions, we put all the demographic questions first, and then we put the depression scale next, and the diet quality scale. And then behind those, we put the DAS, the social connectedness scale, the sleep quality scale, the physical activity scale behind them, so that most of the people, if they got bored at the end or fatigued and left after they've completed the depression, the diet quality scores, we would keep them in, because the others are just covariates and not essential for our data analysis. So we made a decision before we analysed the data, before it was even collected, that we would keep all participants who at least completed the demographics, the depression scale, and the diet quality scale. And then anyone who didn't complete under that, it was fine. We kept them in. So we lost 146 people who didn't complete enough of the data set. So we ended up with 320. And these were our research questions that we are interested in today. We went through these last week. Is there a relationship between diet quality and depressive symptoms in those who eat a plant-based diet? So looking at that research question, there's a word in there that would indicate what type of analysis we would be looking at. What do you think it might be? What's the word and what's the analysis? Yeah, good. Relationship's the word, and correlations is the analysis. So anytime you see a research question with the word relationship in it, it will usually be a correlation analysis. If you see a research question with the word prediction in it, so does diet quality predict depressive symptoms in those who eat a plant-based diet? That'll be a regression. We'll move into that more next week. What about the second one? Do vegans or vegetarians have higher rates of depressive symptoms? This one doesn't have its word in it. That's right. T-test is right. If I could reword this research question in a better way so that you would know. Is there a difference between the rates of depressive symptoms in vegans and vegetarians that would help you a little bit more determine what the test would be? How do we know that it's a t-test? And not ANOVA. I gave you a clue earlier. Between groups is right, yes. Independent measures is also right. How do we know it's a t-test though? Two groups, good. Excellent. So this is really, really important, being able to interpret from research questions what analysis people are using. Okay, so we are going to now go into the data set. Please stop me with any questions that you have. We're going to explore what the data looks like using descriptive statistics first. We're going to look at categorical variables and continuous variables because there's different ways for doing each of these. So here is SPSS. Can everyone see that? Yep, good. All right, so it looks a little bit neater than last week. Here's the gender variable that we cleaned. Gender, it's numeric. All of our widths are now 8. You don't have to do that, I just do. All of our decimals are 0 because they annoy me. Our label is what we want to see underneath our tables or our figures. And then any categorical variables that you have, you need to tell SPSS what your categories are. It's making me, just wait. I'll go back to that later. I've just realized that when I was doing the data characteristics yesterday, the non-binary person didn't come up. Anyway, keep going. Missing data you don't have to worry about. Columns are all 8. I've centered everything. Some of them have changed back to right for some reason. That's annoying. And then I've always made sure that my measures are correct. So gender is nominal because it is a categorical variable. Then we've got age, same thing. Age, always put in brackets how the variable is measured, particularly if it's continuous. That's just to help you out too when you're interpreting your analysis later on. No, you do not need to put in any values for your continuous data, and make sure they're always scale. So the variables of interest today are our demographic variables, because we're going to be looking at descriptive statistics, which describes our sample or our data. So we'll be looking at gender, age. We have used height and weight. So we did this last week. We used height and weight to calculate BMI. So we've got BMI in kilograms, meters squared. Yeah, that's right. I could also, and that's a continuous variable, but I could also change or create a variable for BMI categories by going into the World Health Organization data for BMI and creating a variable that splits this continuous data. If someone's under 18, then they would be underweight. If they were 18 to 25, they would be considered to be average weight. If they were over 25, they would be overweight, things like that. So I can also create variables if I wanted to. We're just going to use continuous BMI. We've created geographical location. Now, this was a string variable where the participants just nominated what country they lived in, and then we created another variable out of that, out of the most common answers. So we've got Australasia, India, the United States, Canada. I considered putting them together because we put Australia and New Zealand together. The Canadians and the Americans probably wouldn't like that very much, so I left them separate. We've got the United Kingdom, we've got Europe. We could put the UK and Europe in together as well. It just all depends on how having conversations in your team is very important. Research should never be done in isolation, particularly analysis. All these decisions need to be made in the team. We've got Africa, we've got Indonesia, we've got the Middle East, and we've got South America. Right, then we've got marital status. In marital status, I have single, de facto, registered partnership, non-registered partnership, married, divorced, and widowed. I could create a variable, partnered and unpartnered. That's what I usually do. I didn't this time, but when I did put them into the participant characteristics table, which should always be table 1 in your results section, I did actually categorize them as partnered and unpartnered. It was easier for the reader to understand. Education levels, same thing. Year 10, year 12, diploma, bachelor's, trade. I changed these to finished high school, university degree, or trade. Then we have our plant-based diet group. Now, we asked the participants to self-report if they were vegan, semi-vegan, vegetarian, semi-vegetarian, lacto-vegetarian, lacto-ovo, pescatarian, flexitarian. And then we categorized them into vegans and vegetarians. So we created a new variable of vegans and vegetarians. Now, the flexitarians were really tricky because they eat meat. So I consider the flexitarians to really not fit into either of those categories. So maybe doing a sensitivity analysis on creating 3 groups and doing a sensitivity analysis just to see if the flexitarians change the data once I've done my regression would be a good idea. And if they don't, then you would just leave it as vegan and vegetarian. So these are all the things that you need to think about. We've got sunlight exposure in minutes and hours per week. And then last week we could be another variable, flexitarian. I don't know how many we've actually got. We can have a look in a sec, actually. We'll have a look how many flexitarians there were. I would assume that most of the people who did this study wouldn't be, but we'll find out. Last week, I showed you how to create a total score for depression, and that's this one here. So the CESD total. Again, when I label these, I label them in a way that says the name of the scale in full, the acronym, what the scores range between, and if there's a cutoff score, and what high scores mean. So for depression, higher scores mean greater depression. So if we were looking at diet quality, where higher scores equal better diet quality, we'd be kind of looking for a negative relationship. As depression goes up, diet quality goes down, or as diet quality goes up, depression goes down. So that's really important and should really be written into your label. We also created the diet quality score. Again, with its label. I'll put the labels up so you can see. So scores on diet quality range between 0 and 105, with higher scores equaling greater diet quality. Social connectedness scores range between 20 and 120, with higher scores equaling a stronger sense of social connection. But the sleep quality scale is the other way around. So scores range between 0 and 84. Higher scores mean more sleep problems. So if we were looking at this with depression, we would probably want to see a positive relationship. So as sleep quality goes up, it's really sleep problems go up, depression goes up. And then we've got the DAS. The depression, anxiety, and stress scores, they're all between 0 and 42. Higher scores mean either greater depression, greater anxiety, or greater stress. That's all of our data. Everything below that are our questions that we used to create our scores. So there's really only 18 variables there. And the IPAC, which is the physical activity questionnaire down here, which I'm still struggling to create a score. That's why it hasn't been done yet. Right before I was doing this, I was trying to do the score. So you'll ignore that today. Okay, we have a question. Is it just a coincidence that diet style is your variable of interest in demographics as well? I have a variable of interest for my research, which I wouldn't put in demographics, institution use, or should I? That's a really good question, Louise. So we want to look at descriptive statistics on all of our variables, every variable, to tell us kind of what it looks like in our population. But always keep in mind that when we run the demographics or the descriptive statistics on these, that it doesn't mean that the relationship or the difference is significant. That's the most important part. The descriptive statistics will not answer your research question, or shouldn't. Can you hide variables in SPSS for neatness? That is a good question. I don't think you can, not like in Excel. I just drag all of my variables of importance up to the top so that they're all there, and I just ignore everything underneath, all the questions. But they're important to keep because just in case you have to go back at any stage. But yeah, just drag everything of importance up to the top. All right. I think we are ready for our descriptive statistics. Are there any questions before we start analyzing? Everyone's doing well. Excellent. All right. To analyze our categorical variables first, I like to do them separately because there's a little bit of a difference. So I always analyze descriptive statistics, frequencies. Keeping in mind, you can rewatch the video on YouTube and fast forward, rewind, go back and follow through when you're doing your own analysis, follow through the steps that I am taking. So analyze descriptive statistics, frequencies. And then this little box will come up. Now for our categorical variables, we want to make sure this display frequency tables box is ticked, because it will tell us how many people are in each category and what percentage of people are in each category. So that's really, really important. So all of our categorical data. Now, can anyone tell me which ones or which icon tells us that it's categorical? Three spheres, good. So SPSS gives you a little bit of a helping hand when you are analyzing things, so you don't analyze the wrong data. So we want to analyze all of our spheres. So everything that's got a red, a blue, and a green circle. So gender, geographical location, marital status, education level, whether they're vegan or vegetarian. We also want to have a look at that flexitarian question. So we'll put the plant-based diet, even though it was one that we used to create vegan or vegetarian, and sunlight exposure. That's it. That's all of our categorical variables. Now, we don't want to see any statistics because the statistics are usually only done on our continuous variables. So the statistics box is not useful here, but our charts box, we could get some bar charts, which will give a bar for each category and how many participants are in each bar. Sometimes they're easier to interpret than the tables. And I always go for percentages in the bars instead of frequencies. Just a personal preference. Then continue. That's it. Also, here is a little sneaky trick you can do now by creating APA style tables. You click that. I've actually turned my whole SPSS into APA 7 output. So if my output looks different, that's why. So I don't need to tick that. It'll do it automatically. If anyone's interested in me teaching you that, let me know and I will I'll teach you next workshop. Is anyone interested in learning how to turn your whole SPSS output into APA 7? Okay, cool. I'll write that down because I have to go back to my PhD student who taught me and ask her to show me again how to do it. Cool. Okay, so that's simple. Then we wait. So if SPSS is sitting here and you're like, what is happening? Has it done it? Down here, it'll tell you what it's doing. So it's not doing anything. It's running the output. It's very slow sometimes. Considering it's only categorical descriptives, it shouldn't take that long. Here we go. So our output has popped up. As you can see here, it's a little bit APA, which is great. You could just pop your table number above that. The heading's already in APA 7, or this is already in APA 7. It's pretty good. All right. So the top box will tell us how many participants are in each category and whether there's any missing participants. Now, this is because we got rid of almost half, about 48% of our data set. We went from 609 down to 320. Our missing values for our categorical, our demographics is quite small. Sometimes you'll have larger numbers depending on what your decisions were on what you would consider to keep. Very important conversation to have with your supervisor. So we've got around 320-ish people. So that's right. That sounds right. For gender, we have 116 male, and we always look at our valid percent. So we've got around 36% of our data set is male. We've got 199 female, so around 62%. In APA 7, you always want to report your percentages as whole numbers. So no decimal places, particularly for your categorical data. All right, so that's pretty good. That's about right for psychology. Gender splits usually, that's actually quite good, having 36% men. Okay, I'm going to ask you a question. What about geographical location? What country were most of our participants from? No. Have a look at the valid percent. India. Yeah. And this was a result of our recruitment. We were recruiting either Australian Indians or people who were in India. One of our the members of our research team is actually a vegetarian due to a faith-based vegetarian because of her religion. So she was very helpful in being able to recruit other people who were faith-based vegetarians. But we've got a pretty good spread of people from different countries. I was really impressed with this. Social media, Twitter in particular, is a very, very powerful recruitment tool now. Facebook used to be really good, but they've changed their algorithms now. It's useless. So a big tip if you're at the beginning of your PhD or a Master's of Research, or you think you might do a PhD one day, is get on Twitter and start following the main kind of authors in your field, and then just going through their friends list and friending anyone who their bio is in your area. That's what I did right at the beginning of my PhD. And now I'm quite well known in my field because of that. So that was a really good tip that I was given. So, and it also becomes an amazing recruitment tool. But you have to be engaged. You have to like people's stuff. You have to share other people's research, all things like that. And it accumulates over time. So you need to be forward thinking in this. You can't just say, oh, I need some participants for my survey, which I'm starting to recruit for. Now I'm going to get Twitter, because it doesn't work like that. You have to be engaged first. So, all right, marital status. We have about 26% singles, 60% married. As you can see, the valid percentage on all the other ones are really tiny. So I would just create a new variable for partnered and unpartnered and look at the percentages for those. That's more interesting for your descriptive statistics when you write it up for your results. All of this goes into like a participant characteristics table. I'll show that to you in a second. So education level, again, this is a very interesting part actually about this data set. What's the highest percentage for education level? Postgrad. That's right. And then what's the second highest percentage? Bachelor's. Yeah. So what does that say about our data set? What's interesting about that? Highly educated. In fact, I get on Twitter, again, I get criticisms from people not in my field, usually carnivores, about how all of my research, all of my participants are highly educated, not overweight, all of these really healthy demographics. They score highly. I'm like, that's because they're vegetarian and vegan. You've just proved your point. So I've been asked to make sure that my data sets are more realistic, because all the omnivores actually have much worse health outcomes. I'm like, I know, I do. All right. So here is the variable that I created for vegan and vegetarian out of the self-report. So what's interesting about our percentages of our vegans and vegetarians? Yeah, we're surprised actually, because when we were recruiting, we had way more vegetarians than vegans. But once we like stripped out those people who didn't complete enough of the data, we actually ended up very even. I've never seen such even groups. So that's great, because our t-test, all of our assumptions will be met in our t-test because our groups are nice and even. It's great. Now, here is the plant-based diet preference. This is what the participants nominated. And this will answer our question that we had earlier about the flexitarians. What percentage of our participants, how many participants were flexi? 4%, and around only 13 out of the 320. So I don't believe that once we do a sensitivity analysis, which is just doing the same study and splitting it without the flexies in there, so we could just take the flexitarians out and redo it. I don't think it's going to impact the analysis at all. 13 out of 320 is quite small. So we could leave them in, we could take them out. That's another decision that the research team has to make. Good. Sunlight exposure. What do we got? What's the most common sunlight exposure per week? Ten to 30 minutes with more than 3 hours closely following. Interesting. Does anyone know what the sunlight exposure recommendations are in Australia? Is it 20 minutes a week? Is it 20 minutes a day? Per day? I thought so too. Yeah. Because we're such a sun smart country, we're all starting to develop a national vitamin D deficiency. So here are our categorical demographics in table form. Very much easier to interpret. So there's our gender, that's the country. So see how in the tables it was tricky to figure out what countries had the most? In table form, it's so much easier. Marital status. And this is just telling us that we should be shrinking these variables like we discussed. Oh, look at education level. That's very, very interesting. As Albie said, not very representative of the general population. Very highly educated data set. There's our vegans. There's our flexies. This is interesting. Pescatarians is the lowest. Very interesting. There's our sunlight exposure. Good. Now, we'll do continuous. No, I might actually give you a break for 5 minutes and then we'll do our continuous variables. How does that sound, Alison?
Sure, let's have a 5-minute break.
Nice.
Okay. See you back here in 5.
See you soon.
Okay, I'm resuming recording now.
Perfect. So Louise has put into the chat box a very, very good question. The question is, so education and plant-based eating are correlated though. So this is a really good point to stop and pause, because descriptive statistics can't tell us whether or not there is a significant relationship or a significant difference between the variables. It's just describing basically how many people are in each one and some interesting information about our data. So it's not until we get to our correlations that we can actually find out whether or not education and plant-based diet is correlated, which we will have a look at. Cool. So let's now move on to our continuous variables. A very similar process. And one of the things that's really important, as you will have seen, is when SPSS spits out your information, is just not looking at it like it's numbers. I always try and go through my data set and bring it back to the real world. What does this mean for my data set? What are interesting things that are happening in my data set? Cool. So to do the descriptive statistics on our continuous data, we go analyze, descriptive statistics, back to frequencies, we reset, so that takes all of the categorical variables out of our box. With continuous variables, it's very important to unclick the display frequency tables box, because it will give us heaps of unnecessary information. Then we want to take every variable of interest that has a ruler, which means that it's continuous. So we're interested in age. Now we've used height and weight to calculate BMI. So height and weight aren't really of interest in our data set. It's more BMI, and it's a terrible indication of health, but the only one that we actually can use at the moment. And then I'm going to pop in my dependent variable, which is depression, my independent variable, which is diet quality. I'm going to pop in social connection, sleep quality. We're going to look at the depression scale, the DAS depression scale. Now, the reason that we've asked this one, it's kind of like a bit of a fact check. So the CESD, it measures depressive symptoms in the general population, and the DAS is more of a clinical diagnostic tool. So if we are looking at the DAS and the CESD, we want to make sure that they're kind of highly correlated and that they're telling us the same thing. If they're not, then there's something going wrong with our data set. So we put that in as a fact check. We also want to have a look at anxiety and stress. So they're all of our continuous variables. Now, statistics this time are very helpful for our continuous variables. So we'd want to look at our average, our mean, our median, our mode, and our standard deviation. I also pop in minimum, maximum scores because they can be helpful, and sometimes skew and kurtosis, but we won't go into that today because it's a little bit, that's more assumptions testing. Continue. Then we want to look at charts, and the correct chart for a continuous variable is a histogram. And we also want to see the normal curve on the histogram. Now, this will be also a really good way of checking our assumption of normality. So looking at histograms and the normal curve. So we will continue and click OK. And we wait for SPSS, a bit faster this time. That's good. And it looks a tiny little bit different. Again, it's in APA 7, kind of, you'd have to fix that up, but it's all right. Across the top, it tells us how many participants are in each category, how many missing. Now, you'll see here that we've got quite a few missing from the BMI category. This is very normal. The weight question in my surveys, I always don't force people to enter. It's a sensitive topic. I'm fine with people leaving that out. But when we calculated BMI, anyone who didn't put weight in would not receive a score. So we've got about 55 missing of those. We've also got around 50 missing from from sleep quality and the DAS. Now, this is just people who got bored of the survey and stopped after kind of the dietary screening tool. But remember, our rule was everyone was included if they had answers had completed all the way up to the depression and the dietary screening tool. So there should be zeros here and missing for those two, because that's the rule that we applied. And this is how many people we could have missed. We could have missed another 50 if our depression and our diet scales were at the end. So that's just a really good tip. What's an overweight BMI score? Does anyone know the answers to that? There's a few categories. This is why we usually categorize them. So you just go to Google. You can create a variable, BMI category. There you go. So less than 18.5 is considered underweight. 18.5 to 24.9 is healthy. 25 to 30 is kind of overweight, but not obese. And then it goes up from there. So if you were really interested in creating a categorical variable for BMI and seeing how many people were in each category, that's a really good idea to do as well in your descriptive statistics, if you're interested in that. All right, so this table tells us our average, our median, our mode, our standard deviation, and our minimum maximum. So let's look at age first. What is our average age for the data set? Around 39 to 40, 39.63. When reporting our means and our standard deviations, we always report to 2 decimal places. That's important. Percentages always to the whole number. What is our standard deviation for age? Around 13. Good. So what this means is that on average, we have our participants would lie between 26 and 52, 53. So that's the range of participants. So this is really interesting in itself. What does this say about the age of our sample? They are. It's quite an old sample, really, considering most psychological research is done on university age students. So 40 is a very mature data set. So we've got some interesting things already coming out. Highly educated, older sample. What's our minimum age range though? What was the youngest person? 13, and then the oldest? Yep, 85. Good. All right, so what about BMI? What was our average BMI? $25. Good. And the standard deviation? About 5.4. So on average, our sample is between 20 and 30 on BMI. What is interesting about that? It's actually the other way around. This is a very low BMI for maybe compared to the general population. I wonder if Google will tell us what that is. Oh, this would be interesting. Trends in adult BMI in 200 countries. Let's have a look. This is good because we have a fair amount of different nationalities in our data set. So this paper, come back, would be really, really good. Global age standardized mean increased from 21.7, so that's higher than we've got in 1975 to 24.2 in 2014 in men, and from 22.1 in 1975 to 24.4 in 2014 in women. So averages are around 22 to 24 by the looks of things. So this, oh yeah, that's about right, isn't it? I thought it was lower. It's lower than what I've seen in my previous studies. That's Christopher has brought up a good point, because most of our data set is made up of Indians. Asian Indian BMI is not the same as for Caucasians. So that's really interesting in itself, and it's something we'll have to go look up to describe in our discussion. So now you're starting to see all these interesting things that are just coming out of the descriptives. All right, then we've got our CSD, or our depression scale. I'm not going to go through all of these, but I am going to go through how to interpret the depression scale and the dietary screening scale, because this is just descriptives. It doesn't tell us whether or not these are significant relationships yet. So what was the average depression score? .27. Now, when we have a look at our label, and we see the range between 0 and 60, and the cutoff for depression is 16, what does that say about our data, about the sample? Yeah, it's pretty good, right? Most of the people in our data set are not experiencing the symptoms of depression. Now let's have a look at the DAS. What's the DAS average? The DAS depression average. Got that right next to the wrong thing. 10.79. And what does our label say? 0 to 42. Higher scores, greater depression. So that seems pretty good too, doesn't it? Yeah. So our vegetarians for life in the descriptive statistics seem to have quite low depression scores. Let's look at diet quality. Our scores range between 0 and 105, with high scores meaning greater diet quality. What's our average diet quality score for our sample? .28. That seems pretty good. However, it's not giving us really that much information because we need to compare this to other papers that have used the dietary screening tool to figure out whether or not other people are getting 64.28. So that's why it's really important in your discussion to be like, this is what we found, this is what other papers have found, and this is what that means. Is this similar or different to other dietary quality scores using this scale and depression scores using this scale? That's why that's a very important part of your discussion. Good, good. All right. Here are our histograms. Now, these give us an idea about our assumption of normality. So age is looking pretty good. I think we've got some young ones that probably shouldn't be in the data set here. I think there was 4 or 5 13 to 16-year-olds. I left them in. There's a couple of older people too. It's looking okay. It's kind of skewed a little bit here. That's fine. What about BMI? What's BMI telling us? What does that histogram tell us? So there's a couple of people here who've got quite large BMIs that are skewing this. So imagine if these people were taken out, these outliers, and we only had this bit here, that would look a lot more normal, wouldn't it? Because of these outliers here, we've got a bit of a skew. Yeah. So here is something really interesting. What is our depression score telling us? Does this look normally distributed? No. Good. However, if you saw a normally distributed depression score, that means most people would be in the middle, tapering out to the 2 corners or the 2 tails. That would not be good, because that means lots of people have like a mid-range depression rather than you. In the general population, this is what depression scores should look like. So even if you don't have a normally distributed score or a skewed score, if that's what you are meant to be seeing, then that's a good thing. Who can tell me why these skewed variables are not of concern in our data set? Why are they not of concern? Heterogeneous, can never say that word, population? Close. What did I say before about sample size and normality? Central limit theorem, good. So we have more than 30 participants. We have more than 30 participants in the vegan and the vegetarian groups. So we would assume that it's okay. We want to see a skewed depression score. We do not want to see a normal distribution. What about diet quality? What's it look like? Pretty good. Looking pretty normal. Good job. Social connectedness, the same thing. It's looking pretty normal. Sleep quality is not. That's what you would see in the general population. You want more people to be down here, remembering that the higher the score, the more acute the sleep problems. So you would want to see people down here with less sleep problems. So you don't want that to be normal. The DAS is telling us the same thing as the CESD. There's a lot of people here who are not experiencing depression, so it's skewed. That's good. Anxiety is showing the same. And stress is a little different to anxiety and depression. There are more people who are stressed, but still the same sort of skewed data. So that's a good thing. Now I'm quickly going to show you what this would look like in a paper. Okay. So the results should start with this table. Table 1, participant characteristics, all of that information in there. Basically, the frequency of people in each category and their percent. And then down the bottom, you've got your continuous data, you've got your means and standard deviations of each of those. Above that should be a little bit of a blurb interpreting the interesting things inside the table. Don't put everything in. That's a mistake. Just the things that are interesting. So how many vegans and vegetarians? That was interesting. Maybe the female-male split, the age, that everyone's kind of just over being a healthy BMI. Just those things, just the interesting things. That it was a highly educated data set. As you can see here, 83% had a university degree. Just the interesting things above the table, describe the table, make sure that you introduce the table in text. Good. Why is that there? Too many things going on at once. All right. So the next thing that we are going to look at, is our assumptions. So who can tell me whether or not our assumption of independence is met? And how? People did the survey once, excellent. No person belongs to multiple groups, good. And no one influenced each other's answers. That's independence, done in the study design. Then we talked about normality, so there's our histograms. Although some of them were skewed, we should see that. We have greater than 30 participants in each group, so we've got a large enough sample size to meet normality. Linearity, we have not tested yet, so I'll show you how to do that. So to test linearity, we would go graphs, legacy dialogues, scatter and dot, simple scatter. And then we want to put the depression scale. Oh, I always get these around the wrong way. Is it first or last? I'm going to put it on the X. I usually have a little note that says which one is which. And diet quality on the Y. We'll see in a second if it's wrong. Okay. Yeah, that looks okay. So here is our scatter plot of each participant score on depression and diet quality. Could we put a line through those dots, do you think? Could we put a straight line through those? Or is it a wave? No. If you're questioning whether you could or not, you can double click on the double click, and it'll bring up this editing box. And then up here is a box that says add fit line at total. If you click on that, it will add your line, close it all off, and then that's your scatter plot line. That's your line of linearity. Now, what do we think? Can we put a straight line through this data? Yay, we can. Good. So our assumption of linearity has been met. Woo! Let's move on. This is also the first step in doing a correlation analysis. So this is a figure of the relationship between depression and diet quality in our data set. And it's a really good way to start off a correlation analysis. Now, when all the dots trend from the top, it depends on which way I'm facing. From the top corner here to the bottom corner here, and they're sloping downwards, that indicates a negative relationship. So as diet quality goes up, depression goes down. If they were trending the other way from the bottom corner here to the top here, that would be a positive relationship. As diet quality goes up, depression also goes up. But we are seeing here a very exciting trend that meets our hypotheses. That as the vegan and vegetarian diet quality goes up, their depression seems to go down. Keeping in mind, this was not a very depressed data set. So we're talking about the people who were. Yes, I'm very happy. That's very exciting. My hypothesis has been met so far. What doesn't it tell us about that relationship? Causal, good. It doesn't tell us whether that's significant or not, although it does have the R squared linear up here, which we'll talk about later. Okay, good. So our assumptions have been met, which is also awesome. So we don't have to do non-parametric testing. Okay, so the next thing that we are going to do is we are going to do correlations. And then t-tests. Okay, let's do our correlations first. Correlations always measure the relationship between two variables. So in this instance, we are interested in the relationship between the dependent variable or the outcome variable and all the other variables. But if we later on want to do a regression, which is what we do next week, we're also interested in the relationship between all of the predictor variables with each other. Because if one variable is highly correlated over like 0.8 with another variable, that means that they're measuring the same thing. And that's not a good thing for your regression. So you would just not include one of those variables. So that's something that we're interested in as well. So let's do that. So we're going to analyze, we're going to correlate, and we're going to bivariate, because bivariate means two variables. So we're only interested right now in the IVs and the DV. So bivariate correlations. So that it's easy to read, I always put my dependent variable in the box first. So it's easy to interpret. And then I put my independent variable next. Then I will put all my continuous variables. So I put age, BMI, social connection, sleep quality, the DAS, anxiety, and stress in. Because these are all continuous variables, we will do a Pearson's correlation I'm just thinking, do I need anything else? No, we've looked at that already. You can also do confidence intervals. We won't do that today because I haven't explained what they are. This tick box down here, flags significant correlations, will give you little asterisks next to the ones that are less than 0.001 p-value and less than 0.05. They're quite handy. Okay, so here are the correlations with our dependent variable, which is the very first column, and our independent variables. So there's a lot of information here that's unnecessary. So you don't really need to be at this stage reading all of this. You can also just read across. So our dependent variable is here. It has a correlation of 1 with itself. So when we're interpreting correlations, they can range anywhere between 1, +1, and -1 with a 0 in the middle. The closer they are to 1, the stronger the relationship. The closer they are to a 0, the weaker the relationship. Negative relationship means as one variable goes up, the other goes down, and a positive relationship means as one goes up, the other goes up. So let's have a look at our depression relationships with diet quality. So who can tell me what the correlation is for depression and diet quality? I'm also going to bring something up. Write it in for me. Okay. To help interpret our correlations, a correlation of 0 is no relationship. Between 0 and 0.3 is weak. Between 0.3 and 0.5 is moderate, and greater than 0.5 is strong. So, what does that say about diet quality and depression? So we've got a -0.26. So as diet quality goes up, what happens to depression? It goes down. Yay! What's our p-value? What's our significant value for that correlation? Yay, we have a significant p-value. So there is a significant negative relationship between diet quality and depression. As diet quality goes up, depression goes down significantly. What's the strength of that relationship? Not strong. It's 0.26. So anything, yeah, weak to moderate. It's, yeah. Which is what we normally see. So this is comparable to the other research that we've done. Okay, let's look at age. What is the correlation for age and depression? This one has got my head scratching a little bit. What's our correlation coefficient for age and depression? It's actually moderate. Oh no, it's weak because it's 0.0. That's right. And it's negative. So as age goes up, depression goes down. What's our p-value? .47. So is that greater than or less than 0.05? Greater than. So is this significant or non-significant? Not significant. Good. And as you can see next to 0.040, there's no asterisks. So all of the variables that have asterisks next to them are the significant ones. So there's no significant relationship between age and depression. That spun me out. So did BMI. There was no relationship between BMI and depression. I've never seen that before, ever. Not sure why. Wonder if I did it categorically, it would do it. Okay, so what are our other significant predictors with depression? You just go along that top row there and find the asterisks. Which ones are our significant? Yep, all the DAS. Social connection, good. And sleep quality. Look at how strongly sleep quality is predictive of, well, the relationship between depression and sleep quality. Nearly as high as depression with itself, as the DAS and the CESD. That's very interesting. Get you good sleep, basically. All right. The next thing that we're going to do, I'm going to quickly show you how to do a correlation with categorical data. So correlate, bivariate, exactly the same, reset, always start with your dependent variable and then pop your categorical variables in underneath that. And then click Spearman's. Spearman's is the correlation that you will do if you have not met your assumptions or you've got categorical data. Exactly the same. Take Pearson's out. We don't need that. And click OK. And you'll get the same thing. So who can tell me what's significant, what categorical variables are significant with depression? Education level, good. Marital status and sunlight exposure. Look what's happening with the diet groups though. That's interesting, hey. There is a perfect negative non-significant relationship between diet type and depression. Not significant though, so it doesn't matter. All right, so that's correlations done and dusted. Pretty easy, right? Next week, we'll come back to these and we will look at the predictor variables with each other and what we need to look at there. But for now, that's all you need to know. Good. The next thing we're going to do is we're going to do group differences. So we're going to answer our second research question. Who has the greatest rates of depression, vegans or vegetarians? What do we hypothesize? I'd like to hear your hypotheses before we analyze the data. What do you think? So there's three different options here. Either vegans have greater depressive symptoms, vegetarians have greater depressive symptoms, or there's no difference. Zoe thinks vegans will have higher depression. Sarah says vegetarians will be less than vegans. Vegans will be worse. Interesting. Let's go and have a look, hey? So we want to analyze. We want to compare means. Now, the reason that we're doing that is because we are taking the two averages of depressive symptom scores for the vegans and the vegetarians that we got from our descriptive statistics, and we're going to see if there's a significant difference between the two. Now, which of our t-tests should we use? Should we use independent samples t-test or paired samples t-test? Independent, good. Why? Different people in each group, great. Let's do that. Boop. So the test variable is depressive symptoms. That's what we're testing the difference in. And the grouping variable is our vegan vegetarian group. Uh-oh. I forgot to do something before I did that. We have to go into the vegan and vegetarian group and figure out how I coded them. So vegans are 1 and vegetarians are 2. Okay, that's important. So make sure you do that when you do t-tests. I always forget. Analyze, compare means, independent samples. Depression goes into the test variable box. Our grouping variable is vegan and veggie, and then we define our groups. Group 1 and group 2. Continue. Options. Don't need any of that. Okay, are you ready? Here is our t-test. Now there's a little bit more information than a correlation. There's a couple of extra boxes. So the first box tells us how many participants were in each category. So how many vegans did we have? $164. How many vegetarians did we have? What was the average score on the CESD for the vegans? Average depression score for the vegans, what was it? 15.04, good. And what was the average depression score for the vegetarians? 13.4. So those who hypothesized that the vegans had greater depressive symptoms seem to be correct so far. But what does this box not tell us? Whether or not this is a significant difference. Good, excellent. So this is what this box tells us here. So the independent samples t-test has one new assumption, the assumption of homogeneity of variance. Now what that means is the variance between the two groups different or equal? Now when we look at significance values for assumptions, we want them to be not significant because you don't want a significant variance. That's what this means. So what's our p-value for our assumptions test? So this is an assumptions test here. What's our p-value for the assumptions of homogeneity of variance? .554. Is that significant or non-significant? Good. So we have no significant assumption difficulties. That is not the correct way of saying it. There is no significant, I can't even think of the words. Our variances are the same. Yay. So when we look at this, we will always go with equal variances assumed if our p-value is not significant, and equal variances not assumed if our p-value is significant. So you don't even have to do a non-parametric test. You just read the line. So we read off the top line. Our t-test is 1.47. What is our p-value for our group differences? The differences between the vegan and vegetarian groups. What's our p-value? 0.142. Is that significant or non-significant? Depends on your alpha. If we're using an alpha of 0.05. No, it's not. So there is no significant difference between the vegan and vegetarian depressive symptoms. And you stop there. And that's what you would report. No significant difference. That makes life easier for me. So that answers our hypotheses. There is no difference between the vegan and vegetarian groups. If this was significant, you could then go on to interpreting the mean difference, which is 1.63. And all that is minusing 13.4 from 15.04. Just tells you what the difference is between the two means. Good. That's t-tests. Nice and simple as well. Next week, we'll move on to what happens when there's more than two groups. Good, good. Perfect timing. Are there any questions that you would like to ask me before we go? No problem. Next week, we will be talking about predicting relationships using regression. So we will be building on what we found in those correlations and showing you how to use that information from the correlation matrix to build your models in your regression. We might even look at logistic regression as asked for, and we will be looking at differences between more than two groups. So ANOVAs. Thank you, everybody. No worries.
Thanks, Megan. I'm quite attached to the final article now. I know that'll be a while yet.
Not really. I've nearly finished writing it, to be honest.
Oh, that's fantastic.
I've got to run the regressions. So I'm running this at the same time as I'm doing the slides up. So I'll run the regressions next week. We don't need to do any ANOVAs because I don't have any questions that can be answered by ANOVA. But yeah, I'll run the regressions next week. If nothing comes out weird, it'll be finished.
That's amazing.
Yeah, there's some really cool stuff in the data that we found.
Isn't it? I was going to just see if you, just wanted to kind of, help us interpret what you found.
Yeah, so even in what we found today, like sleep quality was the highest predictor of depressive symptoms, which is interesting. Usually social connection is, but it was still quite high. All of the covariates were had a significant relationship with depressive symptoms, diet quality as well. The interesting thing for me was that age and BMI weren't significant. That's weird. I've never seen that before. Usually BMI particularly. Maybe it's because the data set is so healthy. So we've got some really interesting discussion points. The fact that the vegans and vegetarians is no difference. Last time we did our data, we did omnivores, vegans, and vegetarians, and there was major significant differences in depressive symptoms between the vegans, vegetarians, and the omnivores. So that's interesting in itself. Do you think higher education maturity could explain the low scores? Absolutely, 100%. The real question of the paper is, does being a vegetarian for life, how does that compare to the other stuff that we've done? So it really looks like being a vegetarian for your entire life is actually very good for you, health and physical measures, which is kind of not what people think, because they're always going on about deficiencies in the vegetarian vegan diet, that it's dangerous for children. I actually still believe that, even though I've done this. But as Albie said, one of the major confounding variables that we can't measure is whether or not it's the diet or the affiliation to religion, because the data set was mainly recruited as faith-based vegetarianism. So is it the cultural, the religion, the beliefs in their religion that's protecting them from these things, or is it the vegan vegetarian diet? So that'll be interesting in the discussion.
Absolutely. Oh, fascinating. Any more questions? Massim, did you have a question, or was it just about the recording?
Yeah, this is actually, I'm quite new in statistics, but I'm really impressed to this workshop. So I hope I will learn a lot. And of course, recorded video will help me a lot actually to recap and to go back again and again, actually, while I will be analyzing my data. I'm the very first year PhD student. So that's why I'm quite keen actually to, and I have focused on psychiatric research also. So I have done same research on the same variables a few days before, which is published in PLOS ON in the
Right.
last year. Yeah, so actually that's fantastic actually, and really thanks and appreciation from my heart to Alison and Megan for organizing such a nice workshop for us.
Oh,
Yeah.
you're welcome.
Thank you.
Thank you very much. This was absolutely wonderful.
Oh, excellent. So, Mason, were you here last week? Because I could send you last week's recording as well, if you like.
Oh, sure. I need that. Yeah, actually.
Okay,
I mean,
no worries.
I missed it somehow. Sorry to say, but I
Okay.
will be really attending all the workshops coming